We have already discussed in the last class range, mean deviation, quartile deviation, three measures of dispersion. Now two more left, that is 10 to 90 percentile range and standard deviation. We will start discussing these two formulas today. So first one we will see 10 to 90 percentile range. The formula is here 10 to 90 percentile range. You might be remembering the notation for percentile P90 minus P10. This is called the percentile range, 10 to 90 percentile range. So you have to find P90 and P10. Remember the formula of your PI, that is for any percentile I can be 10, 90 or anything. The formula will come L plus N by 100 into I minus C divided by F into W. Maybe notation will be a little bit different, but still the things are same. So here L is the lower boundary of the percentile class. Here N is the total frequency. I, that is the suffix that comes with, which is the percentile you are finding, that you have to multiply here, and C is the cumulative frequency of the percentile class, cumulative frequency of the preceding person, just previous one, okay, and F is the frequency of the percentile class, and W is the length of the percentile class. So in this using you are finding the percentile, whichever formula you have studied, you can use that formula. So find the percentile and subtract, you will get the percentile range. Here I have given a data. So I have class and frequency F. What is the class mark here? You can write class mark as the middle value of this. You can write it as 4.5, correct? Then here it will come. Here actually no need to find the class mark, because we are not looking for a middle value over anywhere, like only lower boundary only we have to take. So no need to write the class mark anyhow. Here we have to write the cumulative frequency. So first 4, then 14, likewise added, and we got last 40. The total capital N is 40 here. Okay, so first we have to find P10. So how to write the formula? You have to find N by 4 into I first. So N by 4 into I means what will come? That is N is 40 by 100 into I is 10. 10 means this suffix value, that is into 10. So what is this? This is coming as 4, correct? So here on this side I'll do 40 by 100 into 10 equal to 4, correct? So 4 where comes in this cumulative frequency, here comes 4, exactly 4 value is there. If the given if the value is not in the cumulative frequency, you have to take just above value, that's only. So 4 is given directly here in this cumulative frequency, so the corresponding class you have to take, that is 3 to 6. What is the lower boundary of that? 3. So your L will come 3 plus, then this value we have written here, minus cumulative frequency of just preceding class. There is no preceding class here. This is the first class. So preceding class is not there. The frequency is 0. Divided by F will come, frequency of this class is 4. So 4 I have written into length of this or length of this percentile class, that 6 minus 3 is 3. So this is equal to, what you can write, 3 plus 4 by 4 is 1, 1 into 3 is 3. So this is equal to 6. So your P10 is coming as 6. So I'll wipe here as a whole. Then I'll write P10 as 6. So P10 you have got it as 6. Now what you have to find? P90 you have to find. So what will do? 90 by 100 into, sorry, not 90 by 100, 40 by 100, 40 by 100 into 90, that is equal to 0 cancelled, 9 into 4, 36. So where comes the 36? Here it is 35. So 36 comes in between these two. The next class you have to consider. So this class you have to consider. So your P90, sorry, here already we have written P90. P90 equal to lower classes, lower value is 15 plus this value, that is 36, minus just preceding cumulative frequency, that is 35. So 35 divided by frequency. Frequency of this class is 5. So divided by 5 into length is 18 minus 5 is 3. So this is equal to 15 plus 3 by 5. So this is equal to 15 into 5 plus 3 by 5. So what will come? 50, 75, 78 by 5. Correct? So yeah, this is equal to 128. It will goes 5, then 6 times. Almost correct, I think. 1 28, 5 times 3, 6 times 15.6. So you got your P90 as 15.6. So you can write 15.6. So what is your 10 to 90 percentile range? Equal to P90 minus P10, that is 15.6 minus 6 equal to 11.6. This is the percentile range. Semi percentile range, if you are finding, what you have to do, you have to divide by 2 here. So here also divide by 2. So that will give you 5.8. If it is semi percentile range from 10 to 19, you have to get 5.8. So in both case, in just percentile range you have to subtract, and semi, if it is asking, divide by 2. Always it's ask percentile range only. Semi, it's not that commonly used percentile range. Okay. So this is how we have to find 10 to 90 percentile range. So hope it is clear. So formula only you have to learn. Find both the percentile, subtract it, you will get the range. Now next one we will see. Now standard deviation formula, it is written over here. Standard deviation of a set of n numbers x1, x2, etc. xn is denoted by small s. So standard deviation is denoted by small s, that you remember. This is the notation. This is notation we are using S. So what is the formula for S? I have written two formula here. One is without frequency, one is with frequency. The formulas look almost same. Actual formula S is equal to root of sigma xi minus x bar whole square divided by n. The same thing you can rewrite in this way also. For the calculation purpose, we will use this formula, because we will find sigma x square and will divide by n, and you will find sigma xi by n, that is x bar. This one x bar we will find, for a whole square we will find. This will be easy for calculation than this. So for calculation purpose this formula will use, but it is same as this. So it is the root of sigma xi minus x bar whole square by n. In the similar way, if the frequency distribution is given, you have to multiply the frequency with each class mark, then you have to proceed. So calculation purpose, you can use this formula, that is f into x square you can find, then you find the sum, divide by n minus sigma fx by n, means this will come mean of it, that is square. Once you find mean, you can find square and you find the solution. So these are the standard. Actually here nothing we have new, only that formula you have to apply for the given data, that's only. And there is another name for this, that is called root mean square deviation. Instead of standard deviation, we can tell it as root mean square deviation. That is like a word meaning, like root mean square, mean the deviation from the mean, the square we are taking, sum of that we are taking, that root we are taking, that's called root mean square deviation. Now here when you take s square, so what will happen? For s square, if you take, you will get, it will come sigma sigma x s square, if you take it will become sigma xi minus x bar whole square divided by n. So this is called variance. Variance of a set of data is defined as the square of standard deviation and is given by s square. So if you ask to find the variance, no need to find the root, directly find this value inside, that will give you the variance. If you ask to find standard deviation, you find root of variance. So you can write your standard deviation is same as root of variance, or you can write root of s square instead, where s is notated as standard deviation. Okay, so I have given two problems here. First one, find the standard deviation S of each set of numbers. Here, how many numbers are given? 1, 2, 3, 4, 5, 6, 7, 8. So here capital N is equal to 8. Okay, capital N equal to 8. So first what you have to find? You have to find the mean. Mean we are finding using the formula that we are getting as 9.5 by adding and dividing by n. Then what you have to do? You have to subtract from each x value x bar. So each x value, so first 12 minus 9.5. Likewise each you are subtracting and square of that you are taking. Then you can divide by 8. You will get the answer this. So what is your variance? Variance here it is equal to 23.75. Square of 4.87 is 23.75 variance. In the same way, for a frequency data, here is the frequency data. Height is given, frequency is given. So what you have to do first, you have to find the class mark. We found the middle value class mark over here. Then you have to subtract your mean from each class. So you have to find the mean. So you have to find x bar here, that is equal to sigma fi xi divided by capital N. Here capital N is coming as 100. That is here sigma fi is 100. So here 100 will come. Sigma fi xi you find that you are getting 67.45. So you have to subtract from each. So subtracted, and you have to square each term. So these all terms are squared. So you got in this way. Then you have to multiply the frequency with x minus x bar from the formula. What is the formula? This was the formula. You have to multiply the frequency. So multiplied it and you find the sum of it, you will get 8. So that you have to take here divided by n, that is 100. So you'll get in this way. So this is your standard deviation. So variance is s square, that is 8.5275. So this is the method. The previous problems that you have done, that the same we are using it again and again in the coming problems as well. So here we are getting our standard deviation in this form. So hope you understood. Only thing is you have to remember this formula for frequency, formula without frequency. Now we have a relation connecting these, like a empirical relation between measures of dispersion. We have mean deviation, we have standard deviation, we have semi interquartile range as well. So these three are connected using this empirical relation. It is telling mean deviation is equal to 4 by 5 standard deviation, or in another way we can write mean deviation divided by standard deviation always should be 4 by 5. If it is a good data, it will come in this way, and in the other case you can say me in the quartile range. So in a quartile range, that is quartile deviation, that is semi quartile deviation divided by standard deviation should come 2 by 3. So we divided mean deviation with standard deviation 4 by 5, quartile deviation with standard deviation is coming 2 by 3. It should come, then only it is a standard data. Okay, now so if one is given, you can find the other using this formula also, and whether such a data exists, such a data is good or not, you can check by doing this fraction whether it is coming or not. Now absolute and relative dispersion, we have to check what is mean by absolute and relative dispersion. Absolute dispersion means whatever be the dispersion, all measures of dispersion we have, in whichever dispersion you consider, that you can tell it as absolute dispersion. And relative dispersion means that absolute dispersion divided by average will give you absolute dispersion. So absolute dispersion can be standard deviation, mean deviation, quarterly, anything can come. That is absolute dispersion. Divided by average, you find that will give you relative dispersion. Now a special type of relative dispersion that is named as coefficient of variation. In this case, our relative absolute dispersion we are taking as standard deviation, and average is same x bar. So standard deviation by x bar will tell it as coefficient of variation. We notate it as v. So coefficient of variation is a relative dispersion that you remember. That is the relative dispersion especially for standard deviation alone. So absolute dispersion we are considering here standard deviation. We can consider mean deviation, we can consider quartile deviation, but here to make it as a coefficient of variation term, that you have to take standard deviation by mean. So this is also one formula that can come for examination. Find coefficient of variation will ask. So what you have to find? You have to find standard deviation, you have to find mean and divide it. That will give you coefficient of variation. And if you are asked to find the mean deviation and hence find relative dispersion, that what you have to do? Relative dispersion is equal to absolute dispersion by average. Here mean deviation is asked to find, so you have to find absolute dispersion. You can rename it as mean deviation. So mean deviation by average you can do. So in that way you can find relative dispersion of corresponding to a measure of dispersion. So hope you understood this idea. You have to do one thing, you have to do one problems corresponding to all these from the exercise. First one, 10 to 90 percentile range, one problem, any problem you can choose from the exercise. Choose a problem that is not worked out from the exercise. So you solve one problem for 10 to 90 percentile range, a problem for standard deviation, and preferably you take frequency data. The other one is easy, so you take frequency data, and then you find a problem for to check the empirical relation. One problem you can try from the exercise whether the empirical relations are correct or not. So mean deviation standard, these are if you have, you can check whether it is correct. Such a problem you can try from the exercise. Then you can find relative dispersion corresponding to any one of measure of dispersion. So you can find relative dispersion corresponding to a percentile range. You can find a relative dispersion corresponding to standard deviation. If you are finding with the standard deviation, that can be named as coefficient of variation. For same set of data also you can perform all these things. So take one question from exercise and solve all these formulas. That's all for today. Thank you.